In this video, we'll work out problems on the joint probability distribution. Consider the first problem. First problem is on forming the joint probability distribution. A coin is tossed 3 times. Coin is tossed 3 times. Let the variable x denote. Let x denote 0 or 1. 0 or 1 according as a tail or a head. Tail or a head occurs on the first toss. Occurs on the first toss. Full stop. Let y denote number of tails occur. Number of tails occur. Find distribution, that is probability distributions of variables x, y, and also joint probability distribution of these variables x and y. Now, first here we start with the random experiment. What is the random experiment here? Random experiment is tossing a coin 3 times. Now, we know that in this the total possible outcomes are 8, which is 2 cube. 2 is nothing but number of outcomes in a single toss, heads or tails. It is repeated 3 times. So, this 2 cube, which equals 8. 8 possible outcomes. Therefore, what are the sample spaces then? It is HHH, HHT, HTH, THH. You can write in any order. I am just following some order. HTT, heads 1 time, tails 2 times. THT, TTH, and TTT. Okay. Now, order of S equals 8. Now, the variable x says that it's a rule, we call it f of s, which associates 0 if tails occurs in first toss and 1 when if heads occurs in the first toss. Okay, so then this image set of x takes only 2 values, 0 and 1. This is, you can call it as x1 if you want. It has x2. Okay, now find probability of 0. Probability of 0 equals probability of an event where tails occurs in the first toss. In how many of these 8 outcomes tails occurs in the first toss? Then with these 4 outcomes, TTH, TTT, TTH, THT, and also THH. So THH, THT, TTH, and TTT. So what is this probability then? Total number of outcomes is 4. Order of S is 8. So you are getting 1 by 2. Similarly, what is the probability of 1? X taking the value, the next value 1. It is in the probability of event set where it considering outcomes where head occurs in the first toss. So that is these outcomes you have to consider. This, and this. There is HHH, HHT, HTH, and HTT. So this is also 1 by 2, 4 by 8, 1 by 2. Therefore, distribution corresponding to variable x is this x, p of x, which is nothing but x takes only 2 values, 0 and 1. Corresponding probability values are 1 by 2, 1 by 2. So this is the distribution of x. Probability distribution or the distribution of the variable x. Now, let us consider probability distribution of y. Now, so how the variable y is defined? Y is some other rule, we'll call it as g of s, which is nothing but total number of tails. Total number of tails occur. Okay, since in tossing a coin uh, 3 times, so the possible number of total number of tails occurs or no tail, that is 0, y taking the value 0, one tail in a toss, that is y taking the value 1, then 2, and maximum 3. These are the 4 values taken with the variable y if it is defined like this. Total number of tails occur. Okay, now we'll find the probability of this, each value of the variable y. So p of 0 equals probability, that means number of tails equals 0. That means only if we get all the times heads, then no tails, so 0 I can assign. So only one such outcome. So what is the probability? 1 by 8. Now probability of 1 equals probability of getting tails one time. So exactly in these outcomes, you are getting the tails one time. One is H, H, T, T, H, H, okay, H, T, H. So what is the probability then? 3 by 8. Next, probability of 2, that is total number of tails equals 2. So 3 outcomes, you are getting tails 2 times. One is HTT, TTH, then THT. So what is the probability then? 3 by 8. P of y taking the value 3, the last value. So equals probability that getting tails 3 times, only one such outcome, TTT. So its probability is 1 by 8. Therefore, probability distribution of y, probability distribution of y is y takes the value 0, 1, 2, 3. And what is the corresponding properties P of y? Which is 1 by 8, 3 by 8, 3 by 8, 1 by 8. So these are the individual distributions of x and y. Now I'll find the joint product distribution. For that, we have to find the probability of combination of the value, that is P of xi comma yj we have to find out, or P suffix ij, where x takes the values xi and x takes only 2 values, this taking 2 values and this taking 4 values. Let's understand the form of a table. Exactly, you have to find a joint product distribution which is of this kind in this particular problem. X is 0 and 1. Y take the value 0, 1, 2, 3. Now we have to find out these 8 probability values. This is nothing but probability of x taking the value 0, y taking the value 0. Probability of x taking the value 0, y taking the value 1. Probability of x taking the value 0, y taking the value 2. Probability of x taking the value 0, y taking the value 3. Probability that x taking the value 1, y taking the value 0. Probability that x taking the value 1, y is also taking the value 1. P of 1 comma 2, that is probability that x taking the value 1, y taking the value 2. Probability of 1 comma 3, x taking the value 1, y taking the value 3. Okay, now we'll find this 8 probability values. Now first one, P of 0 comma 0, which equals probability. Now we have to consider the outcomes. I'll write in words. So 0 means x taking the value 0 means tails in first toss, tails in first toss. Okay, 0 means number of tails, 0 number of tails, and no tails. Is it possible? No, because if tails occur in the first toss, at least one tail you find. So certainly, why can't you take the value 0? Okay. Therefore, this is an empty set. So what is the probability then? 0, 0 by 8, 0. Now, P of 0, comma 1 is probability of tails taking tails in the first toss and one tail. So how many such outcomes you find? Tails in the first toss, one tail, THH. Satisfying both the conditions. Tails in the first toss and total number of tails equals 1. Only one such outcome. Its probability is 1 by 8. Next, probability of 0, comma 2. That is tails in the first toss. Total number of tails are 2. How many such outcomes you are finding? You are finding TTH, one outcome, and also THT. Satisfying both the conditions. Tails in the first toss and total number of tails equals 2. So what is this probability then? 2 by 8. Next, P of 0, comma 2 is probability that x taking the value 0, that means tails in the first toss, total number of tails equals 2. Okay, so this is nothing but we already got P of 0, comma 2. Next we can say P of 0, comma 3. So probability that number of tails for tails in the first toss is and total number of tails equals 3. This is nothing but probability of T T T, which equals 3 by 8. Now P of 1, comma 0 equals probability that x taking the value 1, that is heads in the first toss, no tails, that is H H H. This outcome satisfies both the condition. So probability of this is 1 by 8. Next, P of 1, comma 1 equals probability that heads in the first toss and total number of tails equals 1. Heads in the first toss, total number of tails equals 1, that is P of HT H, P of H HT. There are two outcomes satisfying this condition. Its probability becomes 2 by 8. Next, probability of 1, comma 3, 1, comma 2 equals probability that heads in the first toss, total number of tails equals 2. So only one such outcome you are getting, P of HTT. So you are getting 1 by 8. Now P of 1, comma 3. That means x taking the value 1 means heads in the first toss and total number of tails equals 3. This is not possible, and therefore you get an empty set. Therefore its probability is 0. So therefore that required joint probability distribution is this: x, y, x taking the values 0, 1, y taking the value 0, 1, 2, 3, and corresponding probabilities are P of 0, comma 0. We got it as 0, and probability of 0, comma 1 is 1 by 8, and probability of 0 comma 2 is 2 by 8, and probability of 0 comma 3 is 1 by 8, is 3 by 8 I've written, sorry, it is 1 by 8 because there is only one outcome here. Okay. Next, probability of 1 comma 0 equals 1 by 8, is also 1 by 8, and probability of 1 comma 0, after that 1 comma 1 is 2 by 8, and next thing is 1 comma 2 is 1 by 8, and last one is 0. Okay, if you find sum of all these things, you are getting that is equal to 1. Okay, that satisfies the condition, and each one is non-negative. So this is the required joint probability distribution. Okay, now we'll move on to the next problem. In the next problem, we are given a joint probability distribution. Okay, this problem is this: the joint distribution of two variables x and y is given by joint probability distribution PD of two variables x and y is this. Given by this table, x, y, values of x are 1 and 2. Values of y are 2, 3, 4. Now corresponding probability values are 0.06, then 0.15, next 0.09. Next set of values are 0.14, 0.35, 0.21. Now, determine marginal distributions of x and y. Determine distributions of the individual variables x and y. Also, verify that the variables are independent or stochastically independent. Now this kind of problems are very simple. Just what you have to do is, so the values of x are given here, values of y always given here. You have to find out probability of this and probability of this. For that is very simple, because we need not write the formula. Just add this values, that will give you probability of this. Add this value will give you probability of this. That is P1 equals 0.06 plus 0.15 plus 0.09, which equals to 0.3. Then P2 equals sum of the entries in this second row, 0.14 plus 0.35 plus 0.21. This is nothing but 0.7. Therefore, distribution or marginal distribution corresponding to variable x is x, p of x, x takes the value 1 and 2, p of x takes the value 0.3, 0.7. Okay. Now, so marginal distribution of y. So y is taking these values. Now to find probability of 2, just add the sum of the entries in this column. So to get the probability of the sum of the entries in this column, to get the values of probability of 4, get some of the values in this, sum of the values of this column. Therefore, that is P1 bar, we call that 0.06 plus 0.14 is 0.2, comma P of P2 bar equals 0.15 plus 0.35, which is 0.5, and P3 bar equals 0.09 plus 0.21, which is 0.3. Therefore, marginal distribution of y, marginal distribution of y is, so y value in corresponding probabilities. What are the values of y? 0, 1, 2, 3, 4. Values of y are 2, 3, 4. Corresponding probabilities are 0.2, 0.5 and 0.3. You can also verify this distribution. Look here, each value is non-negative. And what is the sum? The sum is 1. Similarly, marginal distribution of x. Each one is negative, non-negative, and the sum is 1. Now, we have to check whether the variables are independent or not. Okay, the condition is this. This is actually P1, P2. This is P1 bar, P2 bar, P3 bar. Now take this value, product of P1 into P1 bar, which is 0.3 into 0.2. What are you getting? 0.06. And this is nothing but the value given here. This value. Okay, that means this equals to P11. Next, P1 into P2 bar equals, that is 0.3 into 0.5 equals 0.15, and this is equal to the value what we find here, 0.15. That is nothing but P12, P12. Next, P1 into P3 bar, that is part of this with this, 0.3 into 0.3, 0.09. This is equal to, with your value what you find here, 0.09, which is P13, P13. Next, P2 into P1 bar, P2 into P1 bar equals 0.7 into 0.2, which is 0.14, which equals to the value what you find here, which is nothing but P small p21. So P2 into P2 bar equals 0.7 into 0.5, which is 0.35, which is equal to the value what to find here, 0.35. Okay, so which is nothing but P22. Next, P2 into P3 bar equals 0.7 into 0.3, which is 0.21, which equals to the value what you find here, which is nothing but P 2 3, small p, small p, 2 3, suffix 2 3. That means here p suffix ij same as property of xi comma yj, which is equal to pi into pj bar for all values of I. Here I take only two values, and j, all values of j here, j takes three values. Therefore, x and y are stochastically independent. Okay, that completes. I'll move on to the next problem. Next problem is, so here we'll be asked to find out the variance, covariance, and the what's called the or instead of that, we take the other problem where you give individual distribution. Okay, so the distributions of x and y, the distributions of two stochastically independent variable, two stochastically independent variables x and y, variables x and y are given in the following table. X, p of x, values of x are 0, 1, 0.2, 0.8. Y, p of y, values are y taking value 1, 2, 3, p of y taking value 0.1, 0.4, 0.5. Now find joint probability distribution. Probability distribution of the variables x and y. So we know that if the variables are independent, we can find out the joint probability distribution. So now just to find the corresponding probability values. Now from the given data, this is nothing but P1, 0.2. This is nothing but 0.8, which is P2. Okay. Now, so P1 bar is nothing but 0.1, P2 bar is nothing but 0.4, and P3 bar is nothing but 0.5. Now you have to find out 6 joint probability values, multiplying this with these values. We are getting 3 joint probability values. In the same way, multiplying this, okay, with these values, you are getting one more set of joint probability values, totally 6. Now we'll find out. So P11, also P11 equals P1 into P1 bar, 0.2 into 0.1, 0.02. P12 equals P1 into P2 bar, 0.2 into 0.4, 0.08. Now P13 equals P1 into P3 bar, which is nothing but P1 is 0.2 and P3 bar is 0.5. you are getting as 0.1. Okay, next we multiply this with all these values, name which will give you P21, which equals P2 into P2 bar, which is nothing but zero point 0.8 into 0.1, which is 0.08. Next, P2 2 equals P2 into P2 bar, which is nothing but 0.8 into 0.4, 0.32. Next, P23 equals P2 into P3 bar, which equals 0.8 into 0.5, which is 0.4. Therefore, joint probability distribution is joint probability distribution is X here, Y here. Values of X are, what are the values of X? The values of X are 0 and 1. Values of Y are 1, 2, 3. That is X values I can take 0 and 1. Y values are 1, 2, 3. And the corresponding probabilities are 0.02, 0.08, 0.1. Next, 0.08, 0.32, 0.4. Take the sum, 0.728, and this is 0.2. So the sum is 1. That means that satisfies the condition, and each one is non-negative. Okay, this is how you can find a joint probability distribution. If you get such a problem, it's very, very simple. Now, in the next problem, and that is the last problem in this topic, we are finding the covariance and the correlation coefficient. A joint probability distribution of the variables x and y is given by this table. X, y, values of x are 1 and 3. Values of y are -3, 2 and 4. And corresponding probabilities are 0.1, 0.2, 0.2, 0.3, 0.1 and 0.1. Now find covariance of the variables x comma y and also correlation coefficient rho of x comma y. To get these two, first we have to find individual distribution. We can find them easily. So individual distributions x and p of x, x values 1 and 3. To get the corresponding probabilities, just find the sum of the entries in the row, this and this. What is sum? 0.1, 0.2, 0.2, 0.5. This also 0.5. Therefore, here you are getting 0.5, 0.5. Now the distribution corresponding to y is marginal distribution y, p of y. And the values of y are -3. Remember, one is negative value, you have to be careful. 2 and 4. And this clearly show that the x and y values need not take the continuous integer value. See, in fact, one of the values is negative here. Okay. Now, to get the corresponding probability, you have to find the sum of the columns, this column, this column, this column. So which are respectively 0.4, 0.3, 0.3. Therefore, the probability values are 0.4, 0.3 and 0.3. Now, we find mean and standard deviation of these two individual distributions. That's what we require to find a covariance and the correlation coefficient. So, mu suffix x is very simple. Sigma x into p of x, which is nothing but 1 into 0.5 plus 3 into 0.5, and this is nothing but 2. Okay. Now, expectation of x square equals summation x square into p of x, which is nothing but 1 square into 0.5 plus 3 square into 0.5, and you get it as 5. Now, sigma x equals, let's find out, e of x square minus mu suffix x square, 5 minus 2 square, which is 1. Therefore, sigma x is nothing but positive square root of this, which is also 1. So, in the same way, we find the mean and standard deviation of this distribution y. Now, mu y equals summation y into p of y. Exactly, it is minus 3 into 0.4 plus 2 into 0.3 plus 4 into 0.3, which simplifies to 0.6. So, e of y square equals, so sigma y square into p of y, which is nothing but minus 3 whole square, now it's become positive, into 0.4 plus 2 into 2 square into 0.3 plus 4 square into 0.3. If you find this sum, you are getting it as 9.6. Now, sigma y square equals e of y square minus mu suffix y square. 9.6 minus, what is mu suffix y? Mu suffix y is 0.6, 0.6 square, which simplifies to 9.24. Sigma y, standard deviation, is square root of 9.24, which is nothing but 3.04. Now, what else we require is expectation of xy, which is nothing but double summation I O and over j xi yj into, so this, how to find out this e of xy? E of xy you can find out using what is called the double summation. Instead of that, we can understand this very easily. You take this distribution, which is the joint product distribution. Take the first value of x, multiply with value of y and the corresponding probability, that is this, plus in the same way this value into this value into this value, plus this value into this value into this value. That means take a value of x, multiply with each value of y, and in the same term multiply the corresponding probability. So that means each term consisting of three constants, x value, y value, and corresponding probability. So in the same way, next, plus this into this into this, plus this into this into this, plus this into this into this. In that way, we can easily find out the this one. So first we consider the value which is 1 into 1 into minus zero point 0.3 minus 0.3 minus 3, sorry, that is the value of y. 1 into minus 3 into 0.1 plus 1 into 2 into 0.2 plus 1 into 4 into 0.2, 1 into 4 into 0.2. I am using brackets to denote the product, plus 3 into minus 3 into 0.3 plus 3 into 2 into 0.1 plus 3 into 4 into 0.1. You find out this using the calculator and you are getting this value as 0. So it's a coincidence that you're getting the value 0 because some of the values are negative. Okay, you do not get 0 always. Here you're getting 0. Now, we require covariance of x comma y, which is nothing but expectation of xy minus mu x into mu y, which equals to 0 minus mu x is 2 into 0.1, 0.6. This is the product of this. You are getting it as minus 1.2. Next, correlation coefficient rho of x comma y equals this covariance of x comma y divided by sigma x into sigma y, which equals to minus 1.2 by sigma x is 1 into sigma y is 3.04, and you are getting it as minus 0.3947. Okay, this is how we can find it. Here you got this as negative. There is a chance of getting this positive. Suppose if you get a value which is greater than this, so then certainly you're getting this as positive. In this case, this is 0, which is less than its product, you're getting as negative. Okay, these are the types of problems you come across in this discrete joint probability distribution. Okay.